Welcome to my channel Mathematical Clinic of Subhasja. In the last lecture we discussed approaching value or x tends to a. We learned that x tends to a or x approaches to a if modulus of x minus a is less than delta. Today we are going to use this theory to establish the definition of limit. Actually, what is limit? To know limit, I am going to take here one example, taking a function fx equal to x square minus 4 divided by x minus 2. If you substitute x equal to 2 here, what happens? Let us check. It will be 2 to the power 2 minus 4 divided by 2 minus 2. It is 4 minus 4 equal to 0 by 2 minus 2 equal to 0. This one is indeterminate. It does not have mathematical meaning. So we noticed that if you substitute x equal to 2 here, an indeterminate form 0 upon 0 comes. It means this function is not defined at the point x equal to 2. Function does not have any particular value at the point x equal to 2. Now let us substitute x approaches to 2 here. I am going to substitute 1.9999 instead of 2 there. What happens? It becomes 1.9999 whole square minus 4 divided by 1.9999 minus 2. Let us use the calculator, simplify it. The result will be 3.9999. Let us check here. If you substitute x equal to 2 here in this function, then function is not defined. Function takes the indeterminate form. But if you substitute x equal to 1.9999, very close to 2, almost 2 is the approaching value of 1.9999. 1.9999 is nearly equivalent to 2. Then we have a value here, 3.99. Now I am going to conclude here. You can say that this 1.999 approaches to 2. If you write 1.9999 approaches to 2, rather than this we could use this symbol equivalent to 2. Then this function fx, where does fx approaches? Value of fx is 3.9999 and this approaches to where? 4. If 1.9999 approaches to 2, then fx approaches to how much? 4. Getting it? So we have substituted x equal to 1.9999. So if x approaches to 2, then the function approaches to fx approaches to 4. If these two results happens together, then we say that 4 is the limit of this function. 4 is the limit of that function fx at the point x equal to 2. Very simple thing. It's not the difficult one. Just you'll have to concentrate here. 4 will be limit of the function fx at the point x equal to 2 only when two things occur together. First thing, x must approaches to 2, and second thing, fx should approaches to 4. If these two things occur together, then we say that 4 is the limit of function fx at the point x equal to 2. Now I am going to use this definition here. Actually, first of all, let us generalize this one. This one is the particular example one. What happens? What should happen to have limit x approaches to a fx equal to L? When does the limit of the function fx at the point x equal to a becomes L? On the basis of this example one, we can say that the limit of function fx at the point a will be L if two things occur together. First thing, what's the first thing? First thing is fx must approaches to L. Fx must approaches to L. And second thing, x should approaches to A. If these two things occur together, for example, in this example one, the x had approached to 2 and fx had approached to 4. So here in place of L it is 4, and in place of A it is 2. Then we were able to say that 4 is the limit of the function fx at the point x equal to 2. Here also in general I am going to generalize that concept one. The limit of the function fx at the point x A is L when two things occur togetherly. First thing, fx should approach to L, and second thing, x should approach to A. Now I am going to use this definition of the approaching value here. Fx approaches to L can be written as modulus of fx minus L is less than delta. Actually, x approaches to A. If the error of x and A is error of x and is smaller than delta 1. Here also fx approaches to L, so error of these two is the modulus of the difference of them must be smaller than delta. Rather than delta, I am going to write here epsilon. And x approaches to A means same thing is written here. X approaches to A, modulus of x minus A is smaller than delta. So we came to the conclusion that a function fx will have limit L at the point x equal to A if for sufficiently small positive real number epsilon and delta, modulus of fx minus L is less than epsilon whenever modulus of x minus A is the less than delta. That's the definition of the limit one. So I'm going to write the definition of function fx have limit L at the point x equal to A if for sufficiently small positive real numbers epsilon and delta. For this one, modulus of fx minus L is less than epsilon whenever modulus of x minus A is less than delta. That I have written. These two conditions have been written here. Modulus of fx minus L, fx approaches to L means modulus of fx minus L is less than epsilon, and x approaches to A means modulus of x minus A is less than delta. If these two things happen together, then we say that fx has limit L at the point x equal to A, and this is denoted by limit x tends to A fx equal to L. Limit of the function fx at the point x equal to A is L. Once again I am going to tell you from the beginning. Here, first of all, we have reviewed our last lecture. In the last lecture we learned that x approaches to A or x tends to A if modulus of x minus A is less than the delta. It means error of x and A is negligible. Here I have taken one example, fx equal to x square minus 4 by x minus 2. First of all, we substitute x equal to 2 here. If x equal to 2, then it becomes 2 to the power 2 minus 4 by 2 minus 2. It is 0 upon 0, which is indeterminate. It does not have mathematical meaning. So function is not defined at the point x equal to 2. Now, rather than 2, I have supposed here approaches to 2. For example, 1.9999. If you substitute x equal to 1.999 here, then it becomes 1.9999 whole square minus 4 by 1.9999 minus 2. Simplify it, you will get 3.9999. Thereafter, we came to the conclusion that if 1.9999 approaches to 1.9999 approaches to 2, then this one is the x. So we have placed 1.999 in place of x. So the value of x equal to 1.999. So if x approaches to 2, then where does fx? This is the value of fx. Where does fx approaches? Fx approaches to 4. So in the example, we conclude that when x approaches to 2, then fx approaches to 4. If these two things happen together, then we say that the limit of the function fx at the point x equal to 2 is 4. We have generalized this concept one here. If limit x tends to 2, fx is equal to 4, to have limit of the function fx at the point 2 equal to 4, these two things should happen together. So if similar concept will be applied here, what can we say? Limit x tends to A, fx will be L when fx approaches to L together with x approaches to A. I have just systematized this result one. First of all, I have applied this definition to this result one. Fx of x approaches to a means what? X approaches to a means modulus of x minus a is less than delta, that is written here. Then by the similar manner, Fx approaches to L means what? Error of fx and L, it means the modulus of fx minus L must be less than delta rather than delta, because delta has been used here. I have to differentiate it, I have used here epsilon. So this will happen, it means the limit of the function fx at the point x equal to a will be L if these two things will happen together. I have just systematized the matter and made the definition. A function fx have limit L, a function fx has limit L at the point x equal to a if for sufficiently small positive real numbers epsilon and delta, modulus of fx minus L is less than epsilon whenever modulus of x minus a is less than delta, and it is denoted by just like this. Now